question number 21, we will solve the same type of question first. So I will give it to you to solve. So we have electric field in this direction, making an angle 37 degree with the horizontal. Take the magnitude of the electric field to be 10 volt per meter. Okay.
Yes, sir.
There are two vertices. Point A, I'm not geometrically showing them. Point A vertex, we can take it as minus 10 comma 0, and vertex B, we can take it as 0 comma 20. Okay.
Yes, sir.
Find the potential at A. Find the potential at A if the potential at B is equal to minus 20 volts. Solve it slowly, don't try to solve it fast. So 1037 degree, I can write the electric field as 8 I cap plus 6 J cap, right?
Yes, sir.
Next, I want VA, VB is given, but to find delta V, I can use minus delta V is equal to E bar dot R bar, right?
Yes, sir.
Where it's my wish to choose what is R bar. So I'm not geometrically representing it, but let us say there's a point P and there's a point Q. It is my wish if I want to choose PQ as R bar or QP as R bar. I can choose either.
Yes, sir.
But if I choose PQ as R bar, then my delta should be final minus initial.
Yes, sir.
Or if I choose QP, then my delta should represent P as final and Q as initial.
Yes, sir.
But there is another way also, like we said, intuitive way, right? What is intuitive way? The magnitude of minus delta V that I have is equal to the magnitude of E bar dot R bar, and I will eventually, because I know higher potential, lower potential stories. So by intuition, I will figure out what is the potential at A. That also I can do, right?
Yes, sir.
Now, let me first apply this story. Okay. Do you want to take A to B or B to A? Do you want A to B? Let's take AB as my R bar. Okay. That means B will become my final, A is my initial.
Yes, sir.
So if I directly want to solve it like this, then I will have minus of, in delta I need to have final minus initial, right? VB minus VA.
Yes, sir.
Is this clear?
Yes, sir.
Is equal to E bar dot R bar. Okay.
But anyway, we're taking modulus, so it doesn't matter.
No. That modulus thing is in between. I put the arrow from the above.
Okay, yes, sir.
From the above. We have done a lot of modulus things. I am trying to show you if I want to directly solve it that way. How? So basically you chose R bar as A to B. That means A is initial, B is final. From that I am using it in delta V, which is VB minus VA, and there's a minus sign outside. Okay?
Yes, sir.
What is R bar over here? R bar is AB bar, because we chose A to B. What is?
Yes, sir. Yes.
Okay. What is AB bar in terms of I cap and J cap?
10 I cap plus 20 J.
10 I cap plus 20 J cap. Fine? Okay?
Yes, sir.
So, minus of, now again substituting from here, minus of VB minus VA is equal to electric field, we got it as 8 I cap plus 6 J cap, correct? Dot
Yes, sir.
product with 10 I cap plus 20 J cap. Clear?
Yes, sir.
This is 80 and this is 120. So you got this as 200. Fine?
Yes, sir.
Minus of VB minus VA. VB is already given as minus 20. Minus VA. Clear?
Yes, sir.
So you can take minus minus outside. Minus into minus will become plus.
Yes, sir.
So we have 20 plus VA is equal to 200. Therefore, my VA is equal to 180. You got this already.
Yes, sir.
Correct?
Yes, sir.
I can get this. See, what is the mod story? Mod story, if I use, I will get that mod as 200. Correct?
Yes, sir.
That means my delta V magnitude, I am getting it as 200. Now what will I do? I'll use my coordinate geometry. A is minus 10 comma 0, so it will be somewhere along negative x-axis. B is 0 comma 20, it will be along positive y-axis. So my A and B are like this, higher potential to lower potential. From diagram also I can figure out. Is
Yes,
this?
sir.
But I wanted to show you even this approach also, because this is not difficult. Unless and until you start practicing, you will not realize that is also
Yes,
very
sir.
easy. Is this clear?
Yes, sir.
Explain it from here. Minus delta V is equal to E bar dot R bar. I only have to choose A to B or B to A. Right? We chose A to B. So that becomes my R bar. That means A is initial, B is final. This initial final story I will use in my delta place. That is minus of final minus initial. VB minus VA. Correct?
Yes, sir.
RHS is anyways dot product. Now in R bar, what is R bar? We have already given R bar as AB bar. So I will use my general basic vector 10 I cap plus 20 J cap. So I got my R bar as 10 I cap plus 20 J cap. Now just substituting R bar here and E bar over here. Correct?
Yes, sir.
So minus of VB minus VA is equal to 8 I cap plus 6 J cap plus 10 I cap plus 20 J cap. Do the dot product, get the 200. Anyways, you could have got the 200 like this or like that. But this way, I only have to choose, am I going from A to B or B to A? Are you getting my point? Once
Yes,
I chose A to B, that means I don't have to actually do any geometry, much of geometry regarding my R bar.
Yes, sir.
Where is my A, where is my B? But that imagination is also important. In certain questions, electric field, so that means this is higher potential, that is lower potential. That imagination is also important.
Yes, sir.
Not in every question, but in many questions, that is also important. In many questions, you can do it like this also.
Yes.
Okay?
Yes, sir.
Solve. Note it down. So, in this question, I want to solve it. Again, all you have to do is choose. Are we going from A to B or B to A?
It is. I think B2A is better because high potential.
That doesn't matter. No, that is wrong. In fact, that is wrong. That doesn't matter. Just heads or tails.
Yes, sir. Okay. A to B.
Okay. So you can choose anything, literally. It doesn't matter. So if I choose A to B as my R bar, then A becomes my initial, B becomes my final. Okay?
Yes, sir.
Now, tell me what is E bar. First of all, I have given the value 50 purposefully. 50 and 53 means 50 will become 40 and 30. So
Yes, sir.
So tell me, what should E bar be?
So it should be 50 and
Bigger angle represents the opposite side to be bigger.
yes, sir.
Obviously, the opposite will take 40 and the adjacent will take 30.
Yes, sir.
So this will be minus 40 I cap minus 30 J cap.
Yes, sir.
What is cos 53?
3 by 5.
So it is 3, right?
Yes, sir.
So adjacent will
Yes,
become
sir.
3, opposite will become 4. That way also you can see
It is minus 40 I cap.
minus 40 I
Plus
cap.
4 I cap.
No, 40 because we have 50 over here, right?
Yes, sir.
So minus 40 I cap minus 30 J cap. In our previous sessions, not only in electrostatics, in previous sessions, we have seen this in vectors. You have a bigger angle, that means opposite side is the heavier one and the adjacent one will be the lighter one, smaller one.
Yes, sir.
50 I know becomes 40 and 30.
Hmm.
Because this angle is bigger, what I will imagine literally is that I will imagine one arrow from here to here, other arrow from there.
Yes, sir. Yes, sir.
Right? That is what I have to
Yes, sir.
imagine immediately. Automatically, I will have minus 40 I cap minus 30 J cap. Now tell me, what is R bar? Because you have already chosen what is R bar in A to B. So what is R bar in terms of I cap J cap?
I have to draw for that.
Draw. R bar is final vector minus initial vector.
Okay, you're telling to calculate. Sir,
Yeah.
10 I cap
10 I cap,
minus 10 J cap.
10 I cap minus 10 J cap. Now,
Highest.
good morning. Now, minus delta V is equal to E bar dot R bar, right?
Yes, sir.
Now tell me, what should I write? What is delta V? First
VB minus V.
is equal to, tell me,
Sir, minus 400
you want
plus
to,
300.
okay, that's nice. Minus 400
Plus 300
plus,
minus 100.
okay, minus 100. Okay, so then we can substitute that also.
VB minus V is 100. Okay.
VA minus VB is 100.
No. Minus minus gets cancelled. VB minus VA is 100.
Oh, okay, is 100. Okay, fine, right. That way also we can do. VB minus VA is equal to 100. VB
VA is.
minus 50.
Yes, sir. No, VA is 50.
It is given VB is minus 50.
Oh, okay, sir. $150, sir.
Minus 150.
Minus 1.
So the problem in that was, I told you that I will solve it, and then I was asking you to solve it. So your brain said, why should I solve it when he said he wants to solve
No, sir.
it? Okay, so this negative will go here, become positive, it is 150, and the minus sign over here will go on the other side, it is minus 150 volts. Okay,
Yes, sir.
Xerox. Done?
Yes, sir.
Here, I want to show you. So one is the imagination, higher potential to lower potential, which we did in the previous session, right?
Hmm.
Now I'm bringing to you into what is initial, what is final, and then substitute it. Instead of magnitude and intuition, I am bringing you to dot product and minus delta V. initial and final story. Because if you look at this question, electric field is given as 30 I cap plus 40 j cap minus 20 k cap. Points A and B are given 0, 1, 0 and 2, 2, 2. VA is given as 10 volts. Find VB.
Yes,
Here,
sir.
in a 3D way, if I want to imagine, although I can imagine, but it will be complicated imagination. I might go wrong in exam.
Why, sir? I mean, there won't be any difference.
There won't be any difference. So you can imagine 30 I cap plus 40 j cap plus 20 k cap vector in a 3D way, right? Because you're so high IQ. So
No, sir.
you can easily imagine 30 I cap plus 40 j cap plus 20 k cap. Next thing is, if there are two points given, Cartesian coordinates, x1, y1, z1, x2, y2, z2. Can you, with respect to your electric field, imagine where is this and where is that higher potential, lower potential?
We can't imagine if 3 coordinates are given, but then we can solve it.
So what I said was, we can imagine, but it gets complicated.
Yes, sir.
Now you came to can't imagine only. Anyways, the reason why I came to this initial final story is these questions you don't have to imagine. The imagination is important. There are certain questions on which are based only on imagination. There are certain questions which are not based on imagination. You can just directly do them, right? So,
Yes, sir.
which one should we take initial? Which one final? Choose.
A to B.
Okay. So if I take A to B as R bar, A becomes my initial, B becomes my final. Simply minus delta V is equal to E bar dot R bar. Correct?
Yes, sir.
So minus of VB minus VA is equal to, what is the dot product? First we need to know what is R bar. What is R bar?
2I cap plus J cap plus 2K cap.
2I cap plus J cap plus 2K cap. Now what is the dot product? E bar dot R bar.
60, sir.
Okay, because 40 minus 40, okay, is 60. Simple. VA is given as 10 volts. Find VB, right?
Yes, sir.
So VB minus 10 is equal to minus 60. I am taking this minus n over there. And I substituted VA as 10. So VB is equal to minus 50 volts. Clear?
Yes, sir.
But even if this is a 3D and difficult to imagine, we can easily finish it off in 1 or 2 steps.
Yes, sir.
Take it down.
I noted it, sir.
Done?
Yes, sir.
Now I will give you a question to solve. Okay?
Yes, sir.
So 24th question. It is given E bar is equal to 5I cap minus 4J cap plus 2K cap volt per meter.
Yes, sir.
A vector PQ bar is given, which is actually your R bar, but there is hidden information over here, which we should use in delta V. I am giving you a hint.
Yes, sir.
A vector PQ bar is given as 3I cap minus J cap minus K cap meters. If potential at P is equal to minus 50 volt, find potential at Q. Don't do any mistake, solve it slowly. Okay?
Then minus 70. Yeah. I got minus 70.
Minus 70. This is 15 plus 5 is 20 minus 2.
Minus 2, 18. Wait, I wrote 20. There I thought 18 in my head, but I don't know.
Okay.
Yes, sir.
So the next one is the derivation actually, but I still want to do it. We have done this earlier, but I am redoing it because I want you to have it in your practice twice.
Yes, sir.
So if E bar is given as EX I cap plus EY J cap plus EZ K cap, and R bar is given as RX I cap plus RY J cap plus RZ K cap.
Yes, sir.
See, R bar is basically representing some vector between 2 points.
Yes, sir.
You can take it as PQ bar or whatever it is, right? But that
Yes.
PQ or whatever AB points, whichever we are interested in, is mainly important when I come to the LHS part, which is minus delta V. So which is final, which is initial, and all those things, I'm only interested when it comes to minus delta V.
Yes, sir.
Because in delta I will substitute final minus initial.
Yes,
So
sir.
if you keep the minus delta V just the same and just do E bar dot R bar. So when we substitute E bar, what will we get? EX I cap plus EY J cap plus EZ J cap, right? Dot product with RX I cap plus RY J cap and RZ. Now when you do the dot product, basically you'll get minus delta V is equal to
EX RX
plus
EY RY plus EZ.
We have done this earlier also.
Yes, sir.
So basically, I can write this as this is responsible for my delta Vx, this is responsible for my delta Vy, and this is responsible for my delta Vz. I gave you imagination of staircase, right? X, Y, X, Y, X, Y. I can do potential differences like that. So simply what I'm trying to say from here is that minus delta Vx can be written as Ex into Rx. Why? Because along I cap, my dot product anyways will be positive because 0 is 1. That way also we can see. So
yes, sir.
From here I can get it as minus dvx is equal to ex. See that Rx I can write it as drx, or I can write it as dx also if calculus is involved. If calculus is not involved, for example, in these situations, calculus was not involved, so it's okay. So either way we can figure it out. Similarly, minus delta Vy is equal to Ey into Ry. And if calculus is involved, I will write the same thing as minus dvy is equal to Ey into dy, right?
Yes, sir.
Similarly, minus delta Vz is equal to Ez into Rz. And when calculus is involved, I'll write it as minus dvz is equal to Ez into dz. And we can rewrite all these things in whichever format we want. Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, Neet UG and other competitive exams. If you're interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. Now, let us do some fun problems. First, we will do some easy problem. Okay. So it is given Ex is equal to x cube. Okay. Find potential as a function of x. What will we do? I know already there is scalar.
Differentiate.
Or
We don't know.
no, differentiate. I'll do it, not differentiate, integrate.
Why, sir?
I'll tell. Wait. Ex is given and he is asking me potential in terms of x as a function of x.
Yes,
As to
sir.
what I'm trying to say is that when such a thing is given, I know I have to go to calculus. In calculus, because I have done this derivation 6 times, 10 times, I know it is minus dvx is equal to ex dx.
Yes, sir.
Even if I forget that.
Yes, sir.
I know negative of change in potential is equal to electric field into distance.
Yes, sir.
That is the format. Next thing is, I just now told, if I am talking of only I cap, why should I bother about the dot product? Because 0 is 1. If I am talking only of j cap, why should I bother? Because 0 is 1. In this question, there is only x everywhere. Obviously, I am talking about x, I cap. So I don't have to worry about dot product. So what do I remember? Negative of change in potential along x direction, because the question is in x, is equal to the electric field along x direction. I don't have to bother about the dot product because cos 0 is 1 into dx. So even if I remember that or don't remember that, I can still come to this. Next, we want potential as a function of x. So simply, I will say integrate on both sides.
I am integrate.
Because I want Vx. If I have dvx, if I integrate it, only I will get Vx.
Yes, sir.
Okay, so I'll take the minus sign outside and I have Vx. Okay,
Yes,
or you can write this as V as a function of x. Both are the same.
Yes, sir.
Is equal to, on the right hand side I have integral of what is Ex? X is cube dx, which is nothing but x to the power 4 divided by 4. Because indefinite integration plus a constant. Fine?
Yes, sir.
So I can write this as potential as a function of x. I will get the answer as minus x to the power 4 by 4 plus c. See, I'm not writing minus c because constant can be positive, negative, that is not a big deal. But I have to show minus sign in front of my function when I remove minus over here. That is definitely important. Is it clear?
Yes, sir.
I'll give the 27th question here only. So electric field as a function of x is given as 3x square plus 2. Find potential as a function of x. Okay, I'm solving this. So basically minus dvx is equal to 3x square plus 2, 3x square plus 2 dx. Correct?
Yes, sir.
So simply
minus of wait.
So minus vx is equal to x cube by 3 will get cancelled. X cube and x
integration of 2 is 2
plus 2x plus c, right?
2x. Yes, sir.
Integral 2 dx is 2x.
Yes.
So Vx is equal to, my final answer will be minus x cube minus 2x plus c. Remember, don't get confused. Why am I not writing minus sign to the constant?
Yes, sir.
Because constant c can be negative, positive. It's our wish.
Yes, sir.
Clear?
Yes, sir.
Now take a look at this question. Okay. Here I have given some variables. Okay. So the idea is, it is given electric field is xi cap plus y square j cap. It is given AB bar is equal to 2i cap plus 3j cap. That means he has given point A, point B, everything is given.
Yes, sir.
A is my initial point, B is my final point, right?
Yes, sir.
And he says if the potential at A is minus 50 volt, find the potential at B. Fine? So first what will I do? First I will go for individual x and y. Okay. So minus
Yes.
dvx is equal to
Integration of 2x.
correct, but because I have already written this, I'll write the entire thing. So basically minus vx is equal to integration of x into dx, correct? Yeah.
Here is 2.
Limits are from 0 to 2, we are saying.
No, I thought it is 2x dx.
No.
No, I can't.
So
Yes.
ex is basically only x. So I just substituted x over here.
But then we have a, b, and c.
We have to come to what is that AB, right? I'll just geometrically show you what is 2i cap and 3j cap. So this is a vector 2i cap plus 3j cap, correct?
Yes, sir.
And in this question, it is already given it is AB bar, so I know it is AB bar. So this point is A and that point is B, correct?
Yes, sir.
And that AB bar vector is represented as 2i cap plus 3j cap.
Yes, sir.
The potential at A is minus 50 volt. He is asking the potential at B. But first I am trying to find the potential difference across this, then the potential difference across this.
Yes, sir.
Clear?
Yes, sir.
So I will go in a slower fashion over here because calculus, as soon as calculus is there, I think. Anyways, so the first line is obvious. We've been using it. In place of ex, I will only substitute what is ex. I don't care what is r bar, what is this chart. Ex is simply xi cap. So ex is x. On the LHS, I have minus dvx. So when I'll integrate, I will get it as minus vx is equal to integral of x dx, right?
Yes, sir.
Or let me show, in fact, even a better way. I will I will integrate on both sides and do a definite integration. What do I mean by definite integration? When I am doing along x-axis, I can say the potential at A is VA. Let me take the potential at this unknown point as V.
Yes, sir.
Okay. So whenever we are doing, we substitute the limits according to whatever is my limits on the RHS, I can substitute in the LHS also. That way also we can see. So if limits for x, if I substitute as 0 to 2, I can substitute this being
VA to V.
VA to V. Are you getting it?
Yes, sir.
In definite integrations, my limits on RHS and LHS should match each other. That's all that is important. I am going from left to right or right to left is also not important. That means if I substitute on RHS 2 to 0, I will substitute on LHS V to VA. So whatever is
Yes, sir.
representing this limit should represent that limit. Whatever is representing this limit should represent that limit. That's the only important thing. Okay.
Yes, sir.
That is about definite integration. But okay. So now doing the integration. So I will get minus of V minus VA, right? Is equal to integral x dx 0 to 2. Integral x dx is x square by 2.
Yes, sir.
So this will come out as,
2.
yeah, 0 to 2 is basically 2 square by 2 will come out as 2. So from all of this integration, I can say my VA minus V is equal to 2, right?
Yes, sir.
Next, let us do the Y part. Okay. Minus dVy is equal to EY into dy, correct?
Yes, sir.
That means integral of minus dVy is equal to integral of EY dy. First, tell me what limit should I substitute anywhere on
V to VB.
V to VB. And what are the limits over here?
0. 2 to 3. No, 0 to 3.
0 to 3. Along y-axis has
Yes,
nothing
sir.
to do about x. Correct?
Yes, sir.
Next. I will also tell you how I am going about this. About the limits also. Yeah. Now, when I integrate the LHS, I will get minus of VB minus V, right?
Yes, sir.
Is equal to RHS integral EY is nothing but y square EY, correct?
Yes, sir.
0 to 3. Integral y square is y cube by 3.
Yes, sir.
How much will this be?
81, no, 21 by 3, 7, sir. Wait, sir, that is x cube, x square. X cube by 3. It will be 27 by 3, sir.
Is 9, right?
Oh,
3 cube by
yes,
3
sir.
is 3 square, which is 9.
Yes, sir.
Okay. 27 by 3 is also 9. Fine. So what did I get from here? I got V minus VB is equal to 9, right?
Yes, sir.
This is my second equation. This is my first equation. This is my second equation. Now adding these two, I can eliminate my V. Minus V plus V will cancel. And by adding 1 and 2, 1 plus 2 when I do, I will get VA minus VB is equal to 11. Correct?
Yes, sir.
VA is given as minus 50 volts.
Yes, sir.
So I can write VB is equal to minus 61 volts. Is this clear?
Yes, sir.
In this question, see, if you remember in the previous sessions we did electric field direction, higher potential, lower potential. Intuition was easy to do. Solving it intuitively was easy to do. Now here there is some y square which is a quadratic, x is some linearly variable. My point is that it's a variable, so forget about direction. Direction is constantly varying. Yeah. So here
Yes, sir.
higher potential, lower potential stories I don't know, but I still got my answer.
Yes, sir.
What I'm trying to say is certain questions. What is the entire basic concept over here in our story? The basic concept is minus delta V is E bar dot R bar. That's the small equation that we had to use over here, right? And
Yes, sir.
these are all applications of that one particular small thing. And we derived y minus delta V is E dot R from our derivation. Work done is force into displacement, blah blah blah.
Yes, sir.
Correct? Wait, I know you're fast. One last thing that I have to explain here is how did I take these limits on RHS? The vector representing along x is 2I cap, the vector representing along y is 3j cap, correct?
Yes, sir.
But he has not given initial value of x is 0, final value of x is 2. The initial value can be 3 and the final value can be 5, correct? But still, because it is not given, I can simply take a reference a as 0, 0 and make things easy for myself.
It's because you wrote 2I cap plus 3j cap. I mean,
Yeah, correct.
yes,
2I
sir.
cap, 3j cap,
It
you know,
can be different from other vectors.
for different coordinates also it can be 2I cap plus 3j cap.
Yes, sir.
Suppose this is 3, 3. This will become 5, 3. And this will become 5, 6.
Yes, sir.
If these vertices are given, our limits will change. It will not be 0.
From 3 to 5.
It will be from 3 to 5. Is this clear?
Yes, sir.
Okay, so here we assumed. So, important thing, we assumed A as origin. Don't forget to write this. Only if we assume it as origin. Otherwise, for different coordinates, we will get different answers. Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.